Math 1332, Chapter 3, Symbolic Logic, Section 4, Logical Arguments, Video 11, Examples of determining the validity of an argument. We're just going to do some examples using the techniques that we've seen in previous videos. So let's begin. Determine if the following argument is valid. Justify your answer. I invite you to pause the video and try to determine its validity and why. So don't just say valid or invalid. All right, the argument is we will go to Six Flags or Hurricane Harbor. John doesn't want to go to Hurricane Harbor, so we will go to Six Flags. Well, we have got a few options on how to begin this. I would like to start it by writing out the premises and the conclusion. So premise 1, we will go to Six Flags or Hurricane Harbor. Premise 2, John doesn't want to go to Hurricane Harbor. Conclusion. And second, while I go grab the therefore sign. It's funny, I can't type the therefore sign, but I can copy and paste it there. And obviously hurricane isn't spelled that way. Wow, I did it twice. That wasn't even a bad copy paste. That was a bad typing job. Conclusion. We will go to Six Flags. Now, you can turn this into symbols, or you can try to recognize a form based on the structure of the premises and the conclusion. Since the first premise is a disjunction, evident by the word or, which we will put a box around, then we have two common argument forms that begin with the disjunction. We have the law of disjunctive syllogism, and we have the fallacy of the inclusive or. To see if it matches one of those, let's identify the structure of this argument by locating the statements on either side of the or. The statement on the left is we will go to Six Flags. That is also the conclusion. The statement on the right in the first premise is, well, it's implied, so we'll write its full sentence. We will go to Hurricane Harbor. And the second statement in the disjunction is we will go to Hurricane Harbor. Is that the second premise? I know the second premise is about John, and the second statement in the first premise is about we. But again, you have to be flexible with subjects, verb tense, as long as it's conveying the same idea. So does the second premise convey the same idea as the second half of the or in the first premise? And the answer is almost, because the second statement in the or says we will go to Hurricane Harbor, and the second premise says we don't want to. So this is basically the negation of the second statement. Now, we could word it so that it was exactly the negation. John doesn't want to go to Hurricane Harbor, so we won't go to Hurricane Harbor, and that would be the exact negation of we will go to Hurricane Harbor. Is this a valid argument form? Hopefully in the previous videos you wrote those down. So if you haven't done it yet, pause the video, go check. Well, we know it's got to be one with the disjunction. So go check the, drawing a blank here, law of disjunctive syllogism. Check that form and go check the form for the fallacy of the inclusive or and see if this matches either. Does it? The answer is, well, yes, it does. This is the law of disjunctive syllogism. That's basically the one that says, all right, this or that, and the second premise says, not this one. Okay, that one. Six Flags or Hurricane Harbor? Not Hurricane Harbor. Okay, Six Flags. It's the law of disjunctive syllogism. Therefore, the argument is valid. And notice I answered both parts of the question. I determined the validity and I justified the answer. Let's try this one. Determine if the following argument is valid. Justify your answer. Random person says, if I don't get something to eat soon, I'm going to get stomach cramps. And later in the day, ouch, my stomach is cramping, same random person. Observer says, I guess he didn't get something to eat. I know it's very trivial and inconsequential, but I want those quotation marks. All right, so is this a valid argument? I invite you to pause the video and try it. I am going to set it up in premise and conclusion form. All right, premise number one. If I don't get something to eat soon, I'm going to get stomach cramps. That is a conditional. The word then is implied, and if it makes you feel better, I'll put it where it belongs. If I don't get something to eat soon, then I'm going to get stomach cramps. What is this next sentence implying? I got stomach cramps. And what conclusion did the observer conclude? I guess he didn't get something to eat. So we'll go ahead and put it in first person. I didn't get something to eat. So, is this a common argument form? And if so, is it valid or invalid? Pause the video and see if you can find an argument form that it matches. Now, this one starts with a conditional, and 5 of the argument forms start with conditionals. 3 of the valid ones, law of detachment, law of contraposition, law of syllogism, and 2 of the invalid ones, fallacy of the inverse, fallacy of the converse. So go see if you can match it, pause the video, and then come back. And here I go. So hopefully you pause the video. To match the argument form, let's analyze the structure of the argument, starting with the conditional. If I don't get something to eat soon, antecedent, then I'm going to get stomach cramps. Premise 2 matches the consequent. I got stomach cramps. The conclusion matches the antecedent. I didn't get something to eat. So, is this a common argument form, and which one is it? If you haven't looked yet, pause the video now and go find out, because I'm about to blow this problem open. This is a common argument form. This is the fallacy of the converse. Go check it if you don't believe me, but it is. Thus, the argument is invalid. Now, if you didn't match it to the fallacy of the converse, then go back and check it. And if you still don't understand, contact me. If you're in my class, you know how to contact me outside of leaving a comment in the YouTube video below. Oh, by the way, if you are in my class and watching this video in Canvas, you can't see the comments below. But if you choose to watch the video in YouTube outside of Canvas, you'll be able to see any comments or leave a comment. Third example, determine if the following argument is valid, justify your answer. And for the record, this is a true story for me, very, very recently. Determine if the following argument is valid, justify your answer. I told my dentist, if my wisdom teeth give me any more problems, then I will have them removed. Because he kept saying, you need to get them out. They're going to give you problems. And I said, well, if I have any problems, I'll get them removed. Well, last week, which is actually a few weeks ago, my wisdom teeth gave me problems. So I will make an appointment to get them removed. Full disclosure, already made the appointment, got them out, not a problem. But let's look at this as a logical argument, starting with the premises and the conclusion. Premise 1, I told my dentist, if my wisdom teeth give me any more problems, then I will have them removed. So let's make that our first premise. Let's see if I can. I'm moving it down because when I'm recording this video, I don't know how much space is taken up in the upper right-hand corner by the video of me. So just to be safe, I don't like to put things up there. All right, if my wisdom teeth give me any more problems, then I will have them removed. Of course. There we go. Premise number 2. My wisdom teeth gave me problems. conclusion. Give me 1 second to go grab the conclusion sign out of Microsoft Word. Oops. Are we still recording? We are recording, okay. Conclusion. I will make an appointment to get them removed. And let's just say instead of I will make an appointment, let's just say I will get them removed. No need to be too verbose there. All right, so if you haven't done so already, pause the video and see if you can match this to a common argument form and then determine whether or not the argument is valid. And in the meanwhile, if you haven't paused the video yet, spoiler alert, here it comes. All right, the first premise is a conditional. My wisdom teeth give me any more problems is the antecedent. The consequent, I will have them removed, which is essentially the conclusion, just in a different verb tense. The second premise, my wisdom teeth gave me problems, is the antecedent. So here is our structure. If antecedent, then consequent is the first premise. The second premise is antecedent. The conclusion is the consequent. Is this a valid argument form? Last chance to check your valid argument forms before I go and let the cat out of the bag. So pause the video if you want to find out on your own. You've been warned. Here we go. This is the law of detachment. I never typed that word right the first time. Thus, the argument is valid. It's really about identifying the structure, matching it to a common argument form. I do have one more I'd like to go over. All of these statements are true, by the way. But the question is, does the conclusion follow logically from the premises? It's not a question of truth, it's a question of logical flow. Determine if the following argument is valid, justify your answer. You know what, let's go ahead and just label these premise and conclusion. Premise 1, I have a dog and I have a cat. You've seen both. Premise 2, if I have a cat, then I have a turtle. Conclusion. Nope, hold on. Forgot I had copied something else. I was about to copy the therefore symbol, but I'd copied something else more recently. Now, there we go. Therefore, I have a turtle, which I do. All right, so is this a common argument form? Well, let's start identifying the structure by locating pieces, simple statements. Premise 1 is a conjunction. I have a dog and I have a cat. And right out the gate, I can instantly tell that this is not a common argument form. Why? There were 7 of them. 4 valid, 3 fallacies. 5 of them started with a conditional. The other 2 started, this is my ring finger. The other 2 started with a disjunction, but none of them started with a conjunction. So I instantly know that this is not a common argument form, but I still want to highlight common statements. It'll help me write this symbolically. Do we have the statement, I have a cat anywhere else? We do, it's right here. I have a turtle is a third simple statement. That's not good. Well, it's not bad, but let's not use red. I use that for negation. Let's use blue. I have a turtle, therefore I have a turtle. I think the translation of these into symbols is not going to be that bad. Let's just use P for I have a dog, Q for I have a cat, and R for I have a turtle. How would the first premise translate symbolically? I have a dog, so that's P, and that's conjunction. I have a cat, that's Q. Premise 2, if I have a cat, that's Q, then I have a turtle. Because it's an if-then, it's a conditional, and we need that arrow. And the consequent is I have a turtle, which is R. And the conclusion, excuse me, I didn't want conclusion there. I want the 3-dot triangle. Therefore, I have a turtle, which is simply statement R. All right, this doesn't match a common argument form, so we can't determine its validity by matching it to a common argument form. We can, however, determine its validity by using the truth table approach. And remember, for the truth table approach, we have to write an implication. The implication is a conditional of a certain form. Trying to decide where to copy here. The conditional is the conjunction of the premises pointing to the conclusion. So let's start writing our implication, excuse me. The conjunction of the premises. So let's get the first premise and let's put it here. But that premise is a compound statement, so it will go inside its own parentheses. Conjunction, the second premise, which is also a compound statement, so it will go in its own parentheses. Close off that to represent the conjunction of the premises, and then that's the antecedent of the implication. So in other words, it's the left half of the arrow. But remember, the symbol for an implication is not just a single arrow, but a double-lined arrow pointing to the conclusion, which is just the letter R. So this is our implication. And remember, we have to have the implication in order to build the truth table to determine if it's a tautology. To show an argument as valid using a truth table, you have to show, excuse me, that the implication for the argument is a tautology. So all we have to do is build this truth table, complete it, and see if it's all true in the last column. The good news is I've already got the truth table set up here. The bad news is it has 8 rows. Why? Because there's 3 simple statements. Notice I've already got all the possible combinations of truth values for P, Q, and R populated. Let me look over them again and make sure that they are correct. Last time I did one, there was a T that snuck in where there should have been an F, or vice versa, I don't remember. And I've already set up the columns, but just to remind you how to make that determination, you use the hierarchy of connectives. So I am going to go to the implication real quick, which I think I would like to make a slightly larger font size. So give me 1 second here. There we go. All right, so I'm going to go to the implication and just quickly go through the hierarchy. 1 second, folks, I'm not sure what's going on here. And quickly go through the hierarchy of connectives to show you that the order is correct for the columns in the truth table. We do have a giant set of parentheses, so we'll go inside of there first. And inside of there, we have 2 sets of parentheses. We'll attack them from left to right. The left parentheses only has 1 connective in it, this conjunction, so we'll do that first. The right parentheses only has 1 connective in it, the conditional, so we'll do that second, as I've already got listed here. That completes both of the smaller parentheses, but it does not complete the larger parentheses, in the middle of which is a conjunction, so that will be third, and that conjunction is represented here. And then outside of the giant parentheses is just this conditional. It is a double line arrow. That just means it's a conditional for an entire argument, also called an implication, but it follows the same rule as a conditional. And that will happen next. All right, so it is the correct order based on the hierarchy of connectives. Let's clean this up and then we'll complete the truth table, hopefully fairly quickly. Okay, first column. This one's easy. It's a conjunction. The rule for conjunction is it's true when all of it is true. So we have to look at each row and see when is P and Q true. Now, we don't need the R in this one, so I'm going to cover it up for a moment. And then in each of the rows, we need to find the rows that follow the rule for conjunction, which is all of it's true. It's all true here, and it's all true here. Those are the only rows that follow the rule for conjunction. So those are the only rows where the P, well, where this column is true. So true, true, and the rest is false. Let's clean this up. Of course, I forgot to mention before starting this truth table that I invite you to pause the video, try to complete the truth table on your own. So if you were waiting for me to say it, now's the time. Otherwise, watch in amazement. But honestly, you can watch me all day long. You need to practice doing it on your own, not just following my lead. All right, let's move to the next column, the Q pointing to R. Since we're needing the Q and the R columns, let's temporarily cover up the ones that we don't need. We don't need the P column, and we don't need the column that we just created. You can cover them up with anything. I wouldn't write over them because we're going to need some of those columns later. All right, so we are looking at Q pointing to R, so we will want to look in this direction, Q pointing to R, in all 8 rows, and implement the rule for conditional, which is what? The rule for conditional is it's true only when T points to F, only when you have that broken promise. In which rows do we have T pointing to F? There are 2 of them. Row 2 and row 6. Those are the only rows that follow the conditional rule false when T points to F. So those are the only rows where we will put false. Let's try this again. There we go. The rest of the rows will be true. So there are the rest of the trues, and I went ahead and cleaned up the mess I was making. All right, moving to the next column. The next column was built around the conjunction, so we're going to play the conjunction rule. But which previous columns do we need to refer to? We need to refer to the one for this conjunction and the one for this conditional, which are these 2 columns. Now, there are no columns in between the one we're populating and the ones we need to refer to, but for consistency, I'll go ahead and cover up the columns that I don't need, not highlight them, cover them up, please, thank you. And play the conjunction rule. The conjunction rule is true only when all true. So in the 2 columns that we're focusing on, in which rows is it all true? First row. That's it. None of the other rows are all true. So this is the only row that follows the conjunction rule, true when all true. So the rest of them will be false. There's the rest of the F's, and now let's clean up the table. And finally, the last column. The last column was built around the implication, which is just a fancy conditional. And let's see what's on either side of it. On the left side of the conditional is this parentheses and all its contents, which are represented by the row we just populated. But the right side is just column R, which is clear over here. So let's cover up all the columns that we're not going to be using, which are these 2 and these 2 in the middle. And now let's calculate the last column using the rule for conditional. Remember that the rule for conditional is it's false only when T points to F. Now be careful. The columns we're referring to are going right to left. In other words, we need the giant parentheses pointing to R. So every row we need to be looking right to left. Are there any rows where we have the broken promise? Any rows where we have T pointing to F? And the answer is no. The only row that could possibly have been T pointing to F is the first row, because the first row is the only one that starts with T. But that did not point to an F, so it didn't follow the conditional rule, false when T points to F, which means that row is true. As are the rest of the rows, because the rest of the rows all start with false, and therefore none of the remaining rows can be the broken promise, because the broken promise starts with T pointing to F. That means the rest of this column is going to be true. And here's our completed truth table for the implication for the argument at hand. Should be pretty straightforward at this point that this is a tautology because the entire last column is all true. Since the implication is a tautology, the argument is valid. Horrible way to end this series of videos. So yes, you can conclude that I have a turtle. And here he is. He's a little shy right now. His name is TikTok. Not after the stupid app, after the character in Peter Pan.